AI is unlocking mind-blowing capabilities to analyze and interpret mass amounts of data. Machine learning pro Drew Reichs is part of a team that created Skywave, a solution that revolutionizes site analysis for environment and infrastructure projects. Check it out.
Yeah, so we're collecting huge amounts of data. We're talking tens, hundreds of gigabytes, even terabytes of data for just a few hundred or 1,000 acres. And so trying to sift through all those different data sets and get meaningful answers out of them can be very complicated. So really, remote sensing and machine learning kind of go hand in hand. Machine learning models want a lot of data, and we have a lot of data, but that data can be hard to go through. So machine learning lets us unlock these data sets.
Beyond computing all of this data, how else are projects benefiting from using this combination of remote sensing and machine learning?
Yeah, one advantage is a lot of these locations are really hard to get to, or they can be really dangerous to access. And so in a lot of cases, we don't even have to put boots on the ground in those areas. We can just go to the parts that are easy to access and safe and get enough ground information. And drones and planes and satellites still allow us to have 100% view of these sites without putting boots on the ground on every square inch.
How do computer models come into play?
Yeah, so sometimes some of these models already exist and we're just building on top of them, but sometimes they're not built for the right scale or the right environment. So sometimes we have to start all over from scratch. But either way, whenever we do this, we're using real world site specific data that we collected on the ground to help train and validate these models. And the validation piece is key here, because even if we don't have to retrain, we always want to validate and make sure that whatever model we're using or building answers the questions for that site specifically. These models can only predict what they've been trained to predict. So if they haven't seen a problem before, they can't answer it. And so some of these sites are very unique. And because we're in the real world environment, these characteristics can change really quickly across geographies.
Where have you seen Skywave make an impact?
It's pretty much applicable to anything you can see on the surface of the Earth. If we can see it with our naked eye, then these sensors are going to see more than our naked eye can. And sometimes with things like LiDAR, it's even going to get below the canopy and see things that aren't apparent on the surface right away either. And then the next question we always get, well, what can you do below the surface? And that technology is advancing, but also because it's the environment, all these things that materialize below their surface manifest themselves above the surface eventually. And so sometimes this can be more nuanced, but that doesn't mean just because it's below the surface, we can't solve problems and understand what's going on below the surface.
Want to learn more about Skywave? Find it on the web at cdmsmith.com/Skywave. Okay, back to Drew. How have you and your team leveraged this approach for urban settings?
So for FEMA, a really important part of their analysis is looking at how housing codes, new urban development codes impact how well these buildings do in the face of disaster. So post-disaster, they send out teams that were built post code updates to see how well they performed after the storm. And so to be able to do this, people in the past were sifting through deed records for when updates happened or when things were built, or turning imagery on and off to see if there was a difference. But by leveraging an existing machine learning model that was already built and just tweaking some of the parameters and the input dates, we were able to flag in a matter of minutes for a whole region in FEMA, a whole southeast of the United States. We were able to flag where buildings had been built because of the signature that those buildings give off.
What about in the natural environment?
Yeah, so after a bridge was moved, we had to monitor to make sure that a tidal marsh environment came back to its natural habitat to prevent erosion. And so to do this, we're using multispectral drones to quantify the amount of above ground biomass that those plants have as they grow. And we can compare that change over time to see how well they're doing, to promote resiliency and to make sure the restoration is advancing as expected.
When you're at conferences and talking to clients, what types of questions are you getting?
Yeah, I think that's interesting, and maybe this isn't what you expect, but people don't understand how machine learning can help them. They just see the problem they have, but the technology and the application is so new that they don't necessarily see how it helps them. And so we like to start by just understanding the problem and then try to brainstorm what data do we have available that's going to help us answer these questions. So it's really getting people to ask bigger, better questions and reframe their thought process around how they do the work they do now.
Drew, it was so great talking with you today. Thank you so much for being here.
Yeah, thanks for having me. Always love to talk about this stuff.